Guys, let's talk about random variables and how that works with a normal distribution. So it'll make sense once we work through this problem, so let's get started. So for a plane to be ready for takeoff from an airport, it needs to be refueled and it needs to have all the passengers' luggage stored. The time it takes to refuel the plane are normally distributed with a mean of 15 minutes and a standard deviation of 2.6 minutes. The times it takes to load the passenger's luggage is normally distributed with a mean of 21 minutes and a standard deviation of 3 minutes. The crew has to refuel the plane first, then they can begin to load luggage. So they're going to do the fueling, then the luggage. Great. What is the probability that the time it will take to be ready for takeoff exceeds 40 minutes? So here's how I approach these problems. Don't even worry about stats, don't worry about variables, don't worry about numbers yet. Just figure out, what does the scenario call for? How do we get this plane ready for takeoff? So as we read through the problem, to get it ready for takeoff, we're going to need to refuel first, then, someone put a plus, add our load luggage, okay? We're going to refuel first, and then we're going to refuel first, then load the luggage, and that will be our total time it takes to get this plane ready for takeoff. So refuel, then load luggage. The next thing I do is I kind of pull out, what's the important information in this problem? Where's my random variables? What are their means, standard deviations, and variances? So one thing they talk about, and we'll call this X, is they talk about refueling. They talk about refueling. And they say the mean for this is 15 minutes. The standard deviation is 2.6 minutes. Now what I'm going to do is I'm going to go ahead and calculate my variance, because just dealing with random variables, I know it's good to have a standard deviation. I know it's good to have a variance. So if you square that, square your standard deviation, you get your variance, which is 6.76 minutes squared. The other thing this problem talks about is loading luggage. That is my other random variable. Okay, loading luggage. They told us the mean time it takes to load luggage is 21 minutes with a standard deviation of 3 minutes, which means the variance is 9 minutes squared. Squared that number. So if I know X is refueling and Y is loading luggage, let's revisit what we're doing. We're doing refueling plus our loading luggage time. That is the total time it takes to fuel this plane. So refueling we represented as X, loading luggage is represented by Y. So the equation we're working with here is X plus Y. So I need to find what is the mean and what is the standard deviation of this operation. And I've done a video on this already, combining random variables. You should go check it out if you need to. But very quickly, if we work through this, because we should all be experts on this now, we're going to take the expected value of X plus Y. You're just going to take E of X plus E of Y. So we're talking 15 plus 21, which is 36 minutes is the average time it's going to take to get this plane ready for takeoff. To find the standard deviation, we're going to start with our variance first. Take the variance of X plus Y. And remember our rules with random variables, expected values, pretty straightforward. Do what you're going to do. Variance, kind of pay attention to what you're doing. Variances and standard deviations are the tricky ones. So if we're going to take two random variables, X plus Y, well, their variances is just the variance of X plus the variance of Y. Okay, so this one's actually pretty easy, which is nice. So our variances, I already calculated those up above, 6.76 plus 9, and I already have this math for us as 15.76. Okay, so that's my new variance, but what we want is we want things in terms of standard deviation. So the standard deviation of X plus Y, aka the standard deviation for the time it takes to get this plane ready, take the square root of our variance, which is 3.97. Okay. Now in our problem, it mentions that things are normally distributed. So I'm going to draw my normal distribution of X plus Y. We know the mean, or the center of this, X plus Y, is 36 minutes. And I know the standard deviation we just calculated is 3.97 minutes. So what I'm trying to calculate is what's the probability that it will take off, the time it takes to get ready to take off exceeds 40 minutes. So that tells me my cutoff point is 40 minutes, which would be to the right. And if we're talking about exceeding, we're talking about the area above. So now we're collecting or combining our random variable knowledge with normal distributions, aka z-score, z-score table, all of those things, okay? So we have our mean, we have our standard deviation. They want to know what is the probability it's going to take more than 40 minutes to get ready for takeoff. So our cutoff is 40. We want the area above. So we'll be doing a z-score of observed, which is 40, minus expected, which is 36, divide by my standard deviation, which is 3.97. You may notice I'm moving a little bit fast in this because all these topics we've kind of become masters of them individually this semester. So we're just putting a lot of things together. If you do 40 minus 36 divided by 3.97 and round that to 2 decimal places, we're talking 1.01 for our z-score. So I want to know what is the probability or what is the proportion of data that is above 1.01. So remember with your z-score tables that we look this information up, you're going to look up 1.01, but remember z-score table always gives you the area below. So when I look up 1.01, I get 0.8438. That doesn't look like 84% of my data. That's because I just got the area below. So I'm going to take that number and subtract it from 1, which gives me 0.1562. 1 minus all this area to the left should give me my area to the right, 0.1562. So what does this mean? 15.62% chance the time it takes to get ready for takeoff exceeds 40 minutes. That's all there is to it. Okay, so kind of a recap here. I know I'm a little bit quick, so let's back it up, get a little recap. Just talk about what you're trying to do. Take your refuel time plus your load luggage time. That gives you your total time. Okay. Next thing I did is I pulled all the information out of my problem. I wrote down my random variable x, my random variable y, pulled out the means, pulled out the standard deviations, got some variances. Then take whatever you're talking about and put it in context of your random variables. So we're talking x plus y. I went in using my rules, figured out my new mean of this combination, my standard deviation of this combination of x plus y. So I had a mean of 36, standard deviation of 3.97. Then put it together with a normal distribution. So I have my normal curve, the center is at 36, standard deviation is at 3.97. Once you have that, you're ready to try and answer the question. They wanted to know what is the probability that the time it takes for takeoff exceeds 40 minutes. Well, have a cutoff of 40, area to the right, got a z-score, use my z-score table to get my proportion, and finally I got my probability or the percent chance that the time it takes to get ready for takeoff exceeds 40 minutes is 15.62%. So this is how random variables kind of combines and collides with our world of normal distributions and how they work together.